Hello, my name is Frederik Steinmetz for aetestplus.com, and today we'll be creating this cube with a light and a camera that we can move around in 3D space. And if you don't think that's anything impressive, I have created this with a simple script containing a couple of lines and actually placed 1000 solids in 3D space just by executing a few lines. So let's get started. And for this, I'm going to start off exactly where we left last time. And this was just to remind you that this here means modulo, meaning you divide a number by, let's say, 10, and you only regard the rest. It means 1 by 10. 1 modulo 10 would be 1, 10 modulo 10 would be 0, and 11 modulo 10 would also be 1. So you divide the number by the second number and only look at what is left. Okay, that is important. Now let's head over to the JavaScript editor. And it's a good idea to start your After Effects script with this. It doesn't matter if you what version you're using. This 8.0 is referring to the CS3 version that I'm using, so I'm guessing that you guys are used to 9.0 or 10.0. All this does is tell the toolkit or the JavaScript editor that the script you're actually composing right now is supposed to be for After Effects, and thereby the debugger and the variable inspector will realize that you're actually writing a script for After Effects. And let's just get started. In After Effects, you don't have to declare variables. You just say x equals, and After Effects will guess for you what type of variable that will be. This is different in the JavaScript editor, and that is for a reason. It's because if you accidentally type, let's say, target in the one variable and then target without the R in the next one, in After Effects you don't get an error message. But here you will, and this is very helpful. If you're looking for your mistake, you're quite happy if the editor checks for spelling mistakes. So I'm gonna create a variable that I call new comp, because we're going to create a new comp for this script. And every time you declare a new variable, you have to type in var and then the name of the variable and then equals to tell the JavaScript editor what this is. And in the script editor, you don't only have the variables text and numbers and stuff like that. You also have objects and compositions, and you have to call those variables by addressing the After Effects application. And for that, you do app and then project.items.add comp. And what this does is it will check the application folder in the programming language of After Effects, and then in the application folder it will find a folder called project and then a called items, and a project can have items like a composition or solids and stuff. And I will call this composition the cube, and then you have to declare the properties, and the properties are the x dimension, comma, the y dimension. The next parameter would be the pixel aspect ratio, and then you have the duration. Let's just make it let's say 10 seconds, 250 frames, and the frame rate would be 25 for my taste. And as always, you terminate the lines with a semicolon. And to this composition, we'll add some objects. I'll call this controller and add a null behind it because I'm not sure if controller is a reserved keyword. As you can see, the global keywords that every JavaScript uses are printed in blue. Numbers are printed in green and strings are printed in red. A string is between two exclamation marks. And you can see that the app project items add comp are all functions that After Effects recognizes, but they're not in the original JavaScript. That's why you have to tell the JavaScript where they are to be found. And unfortunately, this way the JavaScript editor will not realize that these are reserved keywords, and you can't rely that every reserved word is actually printed in blue. Sorry, that was wrong. We have to, oh, actually, sorry, this was wrong. And we have to tell it how to create a null. That would be new comp, referring to this composition, dot layers dot add null. The add null is the actual adding of the null, and I'll just open parentheses and close them immediately. That way the null will have the standard scale, the standard position 0, 0, and the standard dimensions. I don't have to worry about that because it's not important where the null is. And then I'll create the solids variable. The solids, I'll just call them that, and they will be an array. And as you remember, arrays is a container for storing numerous variables. And also I'll add a counter, and that will be a string. And you can see I forgot the space between new and array. And new array just means it's a blank array. New string means it's a blank string. New number would be a blank number, not 0, but blank. It's a little difference, but it's not that important at the moment. Okay, then I'll create a new variable for the width of our objects. And the reason why I'm using a variable is if I want to change the width later on, I'm going to use this width for every row and every column that we create. And if I want to change it later on, I'd have to go through all the rows and columns and change the width every time. So I'll just create a variable for width and height, and whenever I feel like changing the overall size, I'll just change the width and height variables all over here. And then same thing for position. This is the starting point of the cube where we are starting off to creating it. And the position, I keep doing that. It's hard to talk and type. So variable pos x, and I'll just make this 0. Copy that, paste it twice, and change this for a y and a z. So our cube will have its origin at 0, 0, 0. And now we come back to the for loops. The for loop needs, you can remember maybe, you have in After Effects you have the variable, you have the number, and you have the method. So this actually has to be I smaller than 100. And of course this doesn't work in JavaScript. You have to declare this variable I. As I said, After Effects does it for you. So actually that needs to be a semicolon, just as this one. And in this case, I'll actually oh, come on, it's not that hard. So I equals, sorry for that, I equals 1000 in my case. We're going to create a cube with 10 in X, 10 in Y, and 10 in Z. So we use 1000. And I found it to be easier to go from 1000 to down to 1. So I'll type small, bigger or equal 1. And to sum this up again, I create a variable I and it's 1000, and then this I let my for loop check if the variable is bigger than 1, and if not, it will terminate the loop, and also every time the loop runs I will subtract 1 from the 1000. And oh, sorry, this of course is not a line break. We're opening a function here, and JavaScript automatically puts this text indent and puts a little sign over here showing that this is part of a function. It's very handy. And now we'll create the names of the solid, and I will write this down, so later on when I'm inspecting my script, if I don't remember what I've done, this will be very helpful. And you can see that the name of the solids is green, but it's in smaller case than these actual stuff, and that's because I put 2 slashes in front of it, telling the JavaScript editor to disregard everything in this line behind the two slashes until the next line break. Okay, and then we have to differentiate, if that's the right word, between the cubes in the X, the cubes in the Y, and the cubes in the Z position. And we could of course write a couple of if statements, say if we're talking about the X, make it this, and talking about the Y, make it something else. But that's not very elegant, so we're coming back to the divided and the modulo function. First we're checking y minus 1. That is so that the last one is actually 0. Remember, we're stopping at 1. So if we want an actual 0, we're going to subtract 1 from the current loop, and that will make sense later on. And we're checking if this y minus 1 is smaller than 10. And then, if that's the case, we'll have a new function opening the curly brackets, and I'll say the counter equals, and remember counter is a string, so I'll have to put in exclamation marks whatever I want the counter to be, and I'll call it solid, just for the name, 0, 0, and then I'll add to the string plus I minus 1. And adding a variable to a string means it will take whatever is the string's current settings, which is solid 0, 0, and adding into the string, adding the I minus 1. As soon as we're done with the X stuff, I'll arrange the items in Y direction, and for this I'll use an else if, so I can just for the Z I don't have to write if again, I can just write else, meaning if this is the case, or else if this is the case, and any other time else will be the rest. So I don't have to write else if again. And this would be I minus 1. Remember, we're always one step ahead, so we have to subtract that. Is bigger or equals 10. You can see if it's smaller or equals 10, it will execute whatever is planned for the X, and if it's bigger or equal the 10, it will do for the Y. But after we get to 100, we also have to differentiate between numbers that are between 10 and below 100, between 10 and 100. So I'll write and, which is just JavaScript for saying and this also, I is smaller than 100. Then we will execute a new function, and this function would be counter equals, again, solid, but this time we don't need 2 zeros, we only need 1 because our numbers will be from 10 up, and again plus, and then the I minus 1. And as I said, since I use the else if up there, I can just say else, and that means if it's not smaller than 10 and it's not smaller than 100, then else. And this I'll call the counter. Again, this time, since we're above 100, we don't need the 0 in front of it anymore. I'll just add the I minus 1. Okay. And that's it for naming of the variables. I'm sorry, I just realized I made a little mistake, but I'm too lazy to re-record all of this. Actually, this checking if it's smaller than 10, smaller than 100, is only there to check if we need 2 zeros in front of this. Oops, big mistake. That would get us an error message. If you need 2 zeros in front of the solid, or 1 zero, or no zeros, it has actually nothing to do with the placing an X, Y, Z. So just disregard what I said about X, Y, Z in this naming of the solids. It's just so we have them in order. I just don't like it when the solids start with 1 and then goes up to 100 instead of 0, 0, 1 and then goes up to 100. It's just my taste. Let's continue, because now we're going to position the actual layers. So I'll just for later purposes, I'll call this position of the solids, and the position X, which we declared to be 0 before the start of the loop, of course has to be modified using the I. We'll use the I modulo 10 and multiply it by the width, and also to that value we'll add the I, oops, that needs to be in brackets, I modulo 10. And that will mean in every new solid that gets placed, we'll have the X position of, first of all, 1 times its width, this one, which is important because otherwise they would have the position of 1, 2, 3, 4, 5, and this way they'll have the position 1 times width is 20, plus I modulo 10 would be 1, so 21. Okay, now you can see that the X, those will form a square 10 by 10 if we execute this. And now we have to offset this square in Y position every time the square is full. And that would be, for this we'll actually need an if statement, and if I modulo 10 equals 0, and this is important to make two equals, because if you have one equal sign only, that's a declaration, and if you have two equal signs, that is a comparison. I modulo 10 equals 0, so every 10 times this script gets run equals 0, and I'm not typing the I minus 1 because the first run is it doesn't need to be offset. So now I guess you're starting to get why this is from 1000 down to 1 and not from 1001 down to 2 or 999 down to 0. For this, of course, we need the open curly brackets again, and then we'll have the pos y, which is 0 at the first cycle, but it will be increased plus and equal. Oops, we don't need the plus and equal mean, well, pos y plus. It's just shorter. Height, and to the height we'll add 2. And this means every time we're offset, every 10 times the loop runs, the overall y position of our entire square that we created here will be offset. Oh, I'm sorry, it's not the square. The entire line we created here. Every 10 times the loop runs, this will be offset by 2 down, +2. And of course, we also have to check if we did the first 100 squares, then we want to start at 0 again. So I'll make a comparison. If I modulo 100 equals 0, that means every 100 times the loop runs, I want the position y to be reset, because then we'll start at the top left again, but it will be offset once by the next function that we're creating. First we'll have to close both of these functions. The first is for this opening and the second is for this opening, and then we'll check whether to offset the current solid that is created in the current loop of the for loop, whether we have to offset it in z direction. For this I'll write if I modulo 100, so every 100 times the loop runs, equals 0, I will execute this function and it will be pos z to be offset by width +2. And oops, I keep doing that, I don't know why. And we could also declare a variable for the distance between two of the solids, in case we want to change it later on. Since I don't think I'll be using the script for much, I skip this step. I'm sorry, and you can feel free to do this just over here, like I created the variables for this. Whenever you feel like you're gonna be fiddling with those values a lot, you should make a variable, so you don't have to go through your entire script and change the numbers. You can just change the variable up here. And let's continue with the creation of the solids. I'll type that here, creation of the solids. And now we have the solid. This is this array up here, so as I can see it's called the solids. And as you remember, in an array, if you want to address a certain position of the array, it needs to be in brackets, or those, I hope they're called brackets. I will just distinguish these. I'll call parentheses, these I'll call curly brackets, and these I'll just call brackets. And equals new comp, that means it will be placed in our new composition that we created up here. Dot add, and just as we added the null up there, we'll add a solid, and we have to define some parameters for the solid. And the first thing you have to declare is the color of the array. I'll make it white, 1, 1, 1, meaning 100% blue, 100% red, 100% green. And since the color has 3 values in this case, it is an array and it needs to be in brackets. The next thing that will be in these attributes of the solid is the name, and the name has to be a string. And if you remember, up here our counter is a string. That's why I counted anyways. The next is the width, and you guessed right, the height. And then you need the pixel aspect ratio again. Oops, that would be 1, and the duration, that would be 250. That's the length of our comp. And now we created the solid, one for every circle, and now we have to change some of the attributes. You can also type in here some of the attributes you want to change, but that is not good for overview, I think. So I add some of the attributes I didn't put into these brackets, parentheses. I'll just add them now, and that would be the solids and position I again, and then, oops, sorry, dot 3D layer equals true, and you can guess what that does. You just have to know that now the solid number I will be a 3D layer, and if you want to modify properties of the solids, you just need to know how they're called and say the solids dot, and then the property, and then whatever you want them to set it to. And then the solids I property would be the transform properties, and the property we're accessing is called position. Of course, this can be applied to property scale, property transparency, and so on. And dot set value, that means, well, set a value for the position, and the value of course has to be an array. Since we have 3D layer true, it needs to be an array of 3 numbers, and of course position x would be position x, and position y would be pos y, and position z would be pos z, and close parentheses, and also terminate the line. Then one final thing that doesn't look right. One final property we need to add is the parent, the solids dot number I dot parent equals the controller null. And this of course is so we have no problems moving our entire cube around without selecting all our solids in the composition that we're creating later on. And now we're done with our for loop. Since this is not closing all that it's supposed to, I'm very sure I forgot a curly bracket somewhere, and so for now I'll just assume that there's something queer going on with the quirky going on with the debugger, and I'll ignore this problem. Maybe we'll get the error message later on. Just for decorational purposes, I will create a light, var light equals new comp. Of course, that's where it's supposed to be placed, and it should be one of the layers, and we'll add a light, add light, and we'll call it very creatively light. And also we need to put the position of the light, or actually that's the floating point center. It's a 2-dimensional array, and I just use this for now, and I'll alter the properties of the light in the same way I alter the property for the solid. So because I think it's better for overview. And this same thing again, the solids, and this time it's the light, this light dot property dot and then the name of the property, position, very important to write this, spell this correctly, dot set value, and then of course position 3-dimensional array. I found 90 minus 45 minus 150 to be a suitable position. Then also we can, since this is supposed to be a spotlight, we'll set which is standard, so we don't have to define it, light dot property again, property, and the name of the property is point. And if there are several words that's supposed to make up one word, you can't use spaces, because as you can see, if you insert a space, then it's JavaScript will treat it as two different words. So whenever that's the case and you have to guess however your property or whatever is spelled, then your best guess is always to take whatever it's named, and every time a new word starts, you start with a capital letter. And the point of interest, of course, we have to set a value, and again, three-dimensional array, and I found 640, 42, and minus 800 to be suitable. And then we need a camera, since this is all 3D. It's a good idea to make a camera. Call it cam. Again, new comp dot layers dot add, and this time camera. And the camera, of course, needs a position and a point of interest, and also a name. Name it camera. And then this, it's called the floating point value. What's in here? To be quite frank, I don't really know what that means, but 0, 0 always worked for me. And I'll just use those are the minimum required values that you have to give JavaScript. Everything additionally can be set using the cam dot and then the properties, whatever you want to change. Property, and this one will be the position, and we'll transform it by set value, of course. And I had a hunch that 640, 42, and minus 800 would be a good idea. And while I'm looking at my sheet, I realize I use this for the point of interest as well, and the point of interest should be 108 and 20 and minus 42. It's not that easy reading your values of your preset while having to concentrate on not making any spelling errors and explaining all this stuff. And also we need to set the point of interest for the camera, cam.property, and the property's name is point of interest, and dot set value, of course, and three-dimensional array. I chose 20, 142, 200. And while I was going over the script, I realized that first of all we forgot, well, I don't want to blame you, I forgot that the controller null also needs to be a 3D layer. Var, so controller null dot 3D layer equals true. And also let's give it a nice position. Controller null dot property dot name position dot set value, and let's put it to 0, 0, opening brackets, 0, 0, and for the x, since our cube is starting at 0, 0, I want the null to be in front of the cube so we can find it more easily. So I'll just set this to minus 100 to be on the safe side. Okay, and one thing that came to my mind is I said earlier that I want that I want to use the modulo so I don't have to write as many if statements. So I found a way to get rid of this if statement by saying the position z equals math.floor, and you hopefully remember math.floor means you have a decimal number 2.678 and it will remove everything behind the decimal. So math floor of 2.4 equals 2 and math floor of 2.7 also equals 2. So just deletes everything behind the decimal. And the math floor will be used for the I divided by 101. And this time multiplied by the width. And the reason I'm typing 101 is every 101st to be offset, because one square has 100 solids. So this is one way I realized to make things even a little easier. The other method works fine, but I'm always trying to be as elegant as possible with as few lines of code as possible. And I guess this was it. I'll run the script again. And as you can see, our cube is almost centered. We have a light shining onto it, and we have the null object with which we can manipulate the entire cube. I hope you learned something about scripting today, some knowledge that you can actually use. And next time we'll be creating a photo collage containing a couple of photos that would be a pain to position manually. Of course, that's what scripts are for. If you like this, please leave a comment. Let me know if I can improve anything. And I hope I'll see you in the next part of my scripting tutorial. Until then, have a nice day.